Hi, after watching this, you will agree with me that calculations involving electrolysis are the simplest to solve. Let's go. Let's solve. A quantity of electricity liberates 3.6 grams of silver. A quantity of electricity, Q. You don't know that quantity of electricity. It liberates 3.6 grams of silver, which is the mass of silver, from each salt. What mass of aluminium will be liberated from each salt by the same quantity of electricity? So, understanding this question, a particular quantity of electricity liberated 3.6 grams of silver from each salt. And they are now asking me, what mass of aluminium that same quantity of electricity will liberate? Let me find that quantity of electricity first before any other thing. Let's go. Remember that when it comes to solving calculations in electrolysis, I love using my formula. I bring it back. Mass over molar mass is equal to Q over CF. So, let me find that quantity of electricity that liberated 3.6 grams of silver. So, for silver mass, I have 3.6. Q, I'm looking for it. Molar mass of silver given 108. Then charge of silver, I'll write my equation. Silver ion gained an electron to form silver. So since one electron is gained, my charge C is 1. F remains a constant, Faraday's constant for 1 mole of the substance, which is 96,500. Now, substituting this in this equation to find Q, I will have, making Q the subject of the formula, it gives me 3.6 times 1 times 96,500 divided by 108. Q is equal to 3,216.6 coulomb. So this is the quantity of electricity that liberated this 3.6 grams of silver. Now the question is saying what mass of aluminium? So for aluminium, what mass of aluminium will 3,216.6 coulombs of electricity liberate? I'll use my formula again. So I'll still say mass over molar mass is equals to Q over CF. And in this case, I'm looking for the mass because they said what mass? The molar mass of aluminium is 27. Q is gotten already as 3,216.6. Then C for aluminium. I will write my aluminium ion gains 3 electrons to form aluminium metal. So for aluminium, 3 electrons must be gained. So C for aluminium is 3, and F remains a constant, 96,500. Substituting this in that formula, I will have, hence making M the subject of the formula, I will have 27 times 3,216.6 divided by 3 times 96,500. M is equals to 0.299 recurring. Approximately, M is equals to 0.30 grams. And this is my answer. I believe that now you agree with me that calculations in electrolysis remains the simplest. See you.